heard of Vast Data? Even better. So we're pretty new, and this is our first time at VMworld. We've got a booth over there. And so we're storage, and we're awesome storage for Veeam, and I'm going to show you why. So this is the touch screen that is working. Give me a sec here. They said swipe it. Let's see. There's a swipe option. You know what? Okay, I'll just advance it that way. That's fine. Quick plug, myself and Howard Marks will be talking on Wednesday, if you're interested, the case for all flash backups on Age of Ransomware. All right. Okay, so we were at VeeamON in May. It was an awesome show. It was our first time there as sponsors of it. This was at the VeeamON party. If anyone knows how to throw a party, it's definitely Veeam. So shout out to Veeam for that. We are on Veeam's Veeam Ready validation list as a platform for S3 backups and as well as NFS. And we've got our object lock game coming really soon. So our goal at VAST is to eliminate the tiers. And by doing so, what we want to do is break it down for simplicity and make it so everything is fast. So with hard disks, sometimes you got intermittent speeds and stuff. Depends on where it is, if it's fragmented, all those things. In Flash, that kind of disappears. But typically, it's only been a small bit of it because of cost. Cost has typically prevented people from running all Flash for their backups. And so at VAST, what we've got is a huge platform. Our building block started like 675 terabytes for a little 2U box. So it is for very large amounts of data. And we've got, we can go up to into the exabytes with one huge single dedupe domain. And we've got some really interesting licensing options for it too as well, which are kind of game changing. And I want to walk you through our architecture because it's completely different than anything you've seen to date. So until 2018, what we're doing at VAST was not even possible. So these are the three components that we needed to do what we do. One of them is NVMe over Fabric having very, very low latency. The other one is having very dense flash at a low price point. And the thing about this is that it doesn't have the endurance that you need. So then we combine that with like a storage class memory, a 3D crosspoint, which has a ton of endurance, but also lets us substitute that for DRAM to do some pretty cool magic tricks. So in our architecture, we have what we call our C boxes and our D boxes. So the C boxes hold containers. One container per node. The box is 2U. It's got 4 nodes inside of it. And you can put as many of those as you want. These are the ones that serve all the protocols. They got all the brains. And if you want to scale your performance, you add here, independent from here. So traditional disk-based systems, you need to know what size head you were getting up front, or it was a shared nothing system. And as you add those nodes, you have to do a replication factor, and your efficiencies start to go down, let alone not having this huge dedupe domain. So in doing all of this in Flash, we've got all of our QLC and storage class memory, terabytes and terabytes of storage class memory. So we can not only land it in, but keep all of the metadata in there. And the most important thing is we can attach every single drive to every single container. So any of the state lives in the in that container. It's backed by not the memory in it, but the memory here. So if it dies completely stateless, the next one just picks up where it left off. So the guests and stuff don't even know that anything's gone wrong. So with this architecture, we can scale it into exabytes. What's that? How many can go down at a time? Oh, so we have actually have a slide for the erasure coding, and I'll get to that. But it's we can survive lots and lots. So and on the container side of it, those front end nodes, all of the data is available. If you had 100 container nodes there, and 99 of them die, 1 is left, all of the data is available because the other ones had nothing special. You could ask any container node you want, and it has all of it in its memory, which is a shared memory on the back end over that NVMe fabric. So it truly is a different architecture. So up till now, the backup landscape has been tape, purpose-built backup appliances. We got cloud and object and all flash. These are great. The economics kind of got a little better and then not so good. So you want to be over here for your high performance and stuff, but options to date have not given enough reduction and stuff to make that price point make sense. This one, your restores are a little too slow. Restores are definitely slow on a purpose-built backup appliance. If you've got any, I don't know if I'm allowed to say vendor names, but big like dedupe appliances that dedupe in domains of sorts, then those would fall into that category there. Now, so here is the vast system, Veeam on top. Now what's really cool is we've got all the new scalable gateways. That's a new V12 feature on Veeam. And so that architecture where I can add performance by adding those C nodes, I can keep up with whatever kind of levels of service that you want to keep for your environment. All right. Okay, yeah, no, I should have, anyway, shoulda, coulda. So we've got the QLCs that gives us lots of density, and we put a 10-year longevity warranty on that. And the reason we do that is because some people don't believe that we can preserve the write endurance. Well, we can, and we'll just, you know what? We'll just put the warranty behind it, done. And then we do these erasure coding so efficient that we, worst case is a 15% overhead, and we get down to almost 2.5% overhead. And we do a smallest stripe size of 36 plus 4 for parity, and that goes up to 150 disks with 146 data plus 4 parity. You asked me earlier about what can fail. Any disk can fail, and that's one of those 4. And then it starts rebuilding. And then your capacity goes down a little, but you don't have to go replace that disk if you don't want, because you're back up to be able to lose 4 again. And you can keep doing that, and you could lose 4 all at once, and you are still safe with all your data. And then we've got this similarity-based data reduction, which I've got on the next slide here. So compression, as you may be familiar with, is good for files, and you can compress it down and make them smaller, fit it in smaller space. Problem with that is it's just local, right? It doesn't really play off other things. And then we've got dedupe, which is great, but the problem with, one sec here, there we go, look at that animation there, we compressed. Each file is still there. This is the total number of blocks that are landing. Now on dedupe, we need to have exact matches to be able to deduplicate it. And so they would dedupe like this, but if you got a little change, you don't get it. Vast Similarity has both of those, plus this similarity engine, which is like a hybrid of both of those, where what it'll do is make like a Frankenstein reference block that serves both of them, so we can pack even more data down at byte granular levels. And so this is only possible because we're using the flash that we're using that's all byte addressable. Okay, technical talking points on the Veeam side of things. Why do you care for Veeam and Vast? So simplicity, single namespace, performance capacity can scale independently as you need it, and you can scale non-disruptively. You can expand a cluster anytime without disrupting it, and you don't have to go tell Veeam you did anything. It'll just be bigger. And so on the single namespace, single FQDN, and we've got a whole bunch of tricks with our DNS and stuff that we can do to make sure that that's distributed all over the place. So nice and simple up front while taking advantage of everything. And then we've got our single name. You know, all throughout Veeam, if you're really familiar with it, there's a lot of trade-offs that say like, hey, if you're gonna do that, be careful, make sure you're using like a dedupe storage appliance, right? Without that, you may end up with a lot more space. So here's the things that are good for performance and recommended, but without that deduplication, you may not be able to achieve it. Oh, there, swipe work. All right, okay. And it seems to be swiping the wrong way. Okay, simple report, performance capacity reporting. Now I mentioned in V12, you got the scalable gateways. So you can have all these gateways. You want to beat and achieve better SLAs. You can throw more into the mix, whether they're hardware or virtual. And we can take advantage of all that with that infrastructure, that front end that can talk to all of them. So you're not constrained through a little front end straw. Now it's very versatile, space efficient. One of my favorite things in this slide is that we are on the vSphere HCL. So that means that let's say that you've got ransomware, you've got to recover. Where do you recover to? And most people say, well, to my storage. And I'm like, I don't know anybody who's about to wipe it, make space, and then start recovering. I don't know anybody who does that, right? Like, that takes some serious guts to trust it that much. But your business wants stuff up and running. So instant recovery is awesome, but you need some good horsepower behind it. So all the stuff that Veeam's done, we help empower it with a lot of speed. But from there, we could do mass restores or do the storage remotion onto the same appliance that where the backups sit. Now, I wouldn't say put your production and your backups in the same box, But in this case, yeah, restore it there. Take your time, take any kind of proxies, gateways out of the middle so you've got a direct path with your ESX servers, get all the horsepower there to ramp it up, and it doesn't take the space that it would take because the data already exists, even though it's a different format. So it's in VBKs and VIB format, then it comes, you're gonna write it back into with VMDKs. Our technology with that vast similarity on the back end is gonna give it almost for free. It's not 100% match, but it depends on your data, but it's pretty close. So super handy to have in your back pocket. So here's active fulls. This is often recommended even when you're doing synthetics. Occasionally do an active full. A lot of people can't. They just don't have enough space to throw a whole new copy in. No problem. We're taking all the dedupe and stuff on the back end. We're gonna let you fit that in. Now, these are the options you get. You've got the optimal, right, for compression level. We say, yeah, go ahead, leave the default and let it compress and move less over the network. And one of the things is like a lot of storage can't do anything once it comes in compressed. They aren't able to dedupe or anything, and we are able to do that. Now, storage optimization, this is your block size, in case you don't know. This is a 1 meg block size. This is a 4 meg. There's a little red tweak that came out last fall that makes it 8 meg. The thing here is that you may not get the matches because it's pretty coarse, but, you know, and then you can go down the other way and get more granular. But what you'll see is that performance may come at a cost of trying to get more space savings on this side of the house. And every time you make these changes here, you're actually going to need a whole new set of backups because all new hash tables need to be written to start deduping again. So in order for that change to even work for performance reasons, you now need to have like a 100% copy, and now you're waiting for your other stuff to age out. Not a problem. None of those penalties are being paid. Does that sound weird to you or just to me? Okay, it's louder and echoier. Okay, I'll roll with it. Okay, and this thing is there magic on here that's just moving or no? Okay. All right, okay, visibility. Got some cool data flows, capacity analysis. This is when you drill in on our vast UI. We can demo it for you over at our booth if you like. You can click in and then it'll tell you what the data reduction rates are per directory down in there. So per backup job, you can see how good you're getting. And with that, what we can do is, I just changed it over to logical. So in this case, it's a 5.9 to 1 over at this buckets level. And then each one is different. So this direct to S3 is getting like a 17 to 1. But this encrypted one, if you're turning encryption on S3, sorry, you know, we can't do anything with that. It comes in encrypted, we can't find any matches, we can't compress it. It's going to use and land a full amount. So here's an example, just 2 sets, 1 to 1 data reduction. There's no reduction. It's the full size, usable, logical. However, on this one, where we're doing another one through Sober, right, with your scale-out backup repositories, and what we've got are 10 different or 7 different backups going in, and then we can see the data reduction on that is more than 7 to 1. It's 13.5 to 1. And same thing for yet another set, and this one's like a 17 to 1. And just because it was a different job, different place, anywhere it is on the system, it can be, again, scales up to exabytes. All of it's in the exact same dedupe domain, so we can take advantage of all of that. Now, this is just some performance screenshots. This is just a small 1x1 cluster. I'll show you performance in just a minute. These are our data flows. This is the directory that's being accessed, information about it, which of those front-end container nodes it's going through, the VIP that was being contacted, the virtual IP, the host. So these are your Veeam gateways and proxies that show up in here, or ESX hosts, and then the user that's connecting to it. And we can see these flows in real time, and it's super helpful because if you've ever had a backup job, you've added more proxies, more gateways, and it doesn't make a difference. You're like, why not? This is the visibility to know that you didn't have more gateways or you didn't carve it out a different way. And without that, then you might be kind of lost trying to troubleshoot why it's not getting faster. And here, this is just some S3, so we're multi-protocol. All the data is stored in like a proprietary-ish format, but is presented out in standards that are NFS, v3, v4.1, S3, with object lock, SMB, SMB3. And so here's our proxies, and we can see on S3, it's doing a lot more multi-threaded operations, and all of our C nodes are at play here, and we're pushing through performance here. So the performance is fantastic. If you want to fire up the best that Veeam has on the instant recovery data labs, this is the platform to let you do it, like make the most out of it. So this is just a little job running. I wanted to demo. Backing up doesn't always make very good demos. You kind of sit and watch. So anybody who smiles, like, yeah, I've worked with backup. So you kind of wait for a little while. Often you may have like that long tail job that like, oh, I wish that big one would finish, and you're just kind of waiting for it. And then what I wanted to show is as I go through the analysis here, you know, there's different bottlenecks, but target is not the bottleneck in this case. And we were pushing over 4 gigabytes per second. You like that one? That's the magic of television right there. Yeah. So, and I'm not going to pretend like I didn't do that, right? But these are real numbers here, and these are real screenshots. So here again, the scalable gateways, you can add more, and if you kind of saturate that front end, just add more front ends to it to make it go faster and scale together. And over here, again, when we get into choosing this, there's a lot of things that say, hey, make sure that you've got some kind of deduplicating storage if you're going to use these best features. So these are best for performance, but they come at a penalty if you're not deduplicating. And then when you're choosing multiple ones, you have to make some decisions. There's some trade-offs here, performance or disk capacity. None of this matters. All of it's in the same place, back end. Anything that's not right, we pick up the difference and compress it down, dedupe it down and stuff. So SSDs are, of course, recommended for the write cache and stuff. SSDs are flash, but typically you just can't get an all-flash system at the economics cheaper than disk until we're doing it now. So that's why I'm at VAST. I think it's a pretty big deal. Again, these are the components of it. NVMe switch in the middle. These are typically Mellanox. For the biggest environments, they'll be InfiniBand. The C boxes are a 2U server with 4 nodes in it. They run a container per, completely stateless. Any of them can fail as long as one's still alive, you're all good. And this is capable of up to 38 gigabytes per second a read, right? So these restores that you really, really, really need, we've got it, because our restore speeds are about 8x our backup speeds, and our backup speeds are fast. Our backup speeds are coming at our smallest cluster around 5 gigabytes per second. And you might be wondering how the networking on this works. Here's those C nodes. Here's that switch in the middle. We can either put additional NICs on there and plug into all the different environments to talk to those Veeam gateways or the rest of the environment. Or most customers do a big MLAG off here. They'll do anywhere from 2 to 16 100 gig ports into their network so they can push as much as they need. Maybe 2 MLAGs, one into a prod, one into a non-prod, so that stuff doesn't cross the core when they're going through. We've got a lot on the security side of the house, so you can know your data's safe. So the encryption part, I told you you get penalized if you were putting encrypted objects in, but they can land in and be encrypted at rest. And so we do have FIPS validated ciphers in there for both the data and the metadata. We can take our exports and our shares and buckets and stuff and create security policies that only allow them out certain C nodes or from certain guests to come in. So a lot of granularity there. And we've got immutability. So we've got indestructible snapshots. They can be released through a process, a special process between you and VAST. 2 people drawing some blood and exchanging keys and stuff. But if you ever made a mistake on the config, there is a way to undo it. Otherwise, that's locked. Even you as an admin, there's no way to undo it unless you go through that process. So it is really good from a ransomware if there's an insider perspective. That even your admins can't turn against you and make an extra couple $100K because they're going to look the other way while someone does something bad. Because anyone who tries to ransomware somebody who has valid backups, it's not as convincing as the person who has no options, right? So backup systems are targeted. And these are good safeguards to put in place to protect it. So we've got full API first architecture. How's that helpful? On your pre-post jobs, you can use that. So if you wanted to do an indestructible snapshot after, before, all of those are very simple, easy to do. Centralized management for it. And we've got thousands of metrics to dig into, so you can keep it simple or you can dig in. And again, come to the booth and you can check out all what these metrics are. And then that capacity estimation that I showed you comes down and shows you where your data is kind of going and how it's being used. And with that, one more piece that's pretty interesting is that instead of having, we have set out from a design perspective to go 10 years on a cluster. So any component that you buy today, we're assuring that that stays in the cluster 10 years down the road from now. So we're not going to end of life it. It's there. You keep building onto it. So that is part of the design, so that you don't need to do that, and you don't have to move through these refresh cycles, which are a real pain because you know how sticky they can be in the backups and stuff, right? And we've got this amazing Copilot support through Slack. You can get level 3 engineer on with you. They'll know your environment pretty well. They'll help you through stuff. You can ask about everything. Access to lots of experts, you know, on all the topics around Veeam, data protection and stuff. I've helped a lot of customers with their deployments and stuff. And, you know, happy to help assist, you know, anything you're doing to make sure you're successful at it. And our customers say, yeah, we love Vast, right? So that's why we've got this slide with the 4 and 5 stars. And with that, I just want to thank you very much. I had a lot to power through, and I appreciate your time here while I go through.
Let's give Rob a big round of applause. All right, thanks, Rob.